Hi, again, this is Ahmed with another video. Just because the midterm is around the corner, I just want to go to some of the examples for matrix. And it's the mathematical economics in Carleton. It's an Econ 3001. So it's a third year economic course, Econ 3001. And also, most of the questions will come, it's from a linear models and matrix algebra. Let's do just a few examples, so that makes it very easy. And then let's say if you have an example that reads that if you're giving a matrix and that matrix is a square matrix where you have 24, it's an 8, and 9, and -3. So the question is that to determine if the rows are linearly independent. So that's the question. Since we have a square matrix, so it's going to be very easy, and the easiest way that you can determine whether they are linearly dependent or not is to take the determinant of A and then see if that determinant is not 0. Then that's telling you that the rows are linearly independent. If it is not, then so the rows are linearly independent. If the determinant of A is equal to 0, then the rows are linearly dependent. So therefore, since we have this example, let's take the determinant together, and determinant of A is equal, since we have a square matrix, I would say before. I think I went in details how you calculate the determinant, but I'm just gonna go again, and then let's say if this is your A, this is B, this is C, and this is D. If you want to calculate the determinant of A, then that's going to be A diagonal multiplication, A times D, which is D here, A times D minus B times C, then minus B times C. This is how you take the determinant. Now it's just a matter of multiplication. Usually students make a mistake with this minus signs when they see this minus and minus, and they get different result. And that's gonna, if you have a wrong one where you have non-zeros and then you ended up getting 0 answer, just because you made a mistake of flipping the signs, then that's going to have a wrong answer for you. So therefore, I would suggest that you make sure that you do this kind of diagrams in terms of when you take the determinants. So are you trying to determine whether the rows are linearly dependent or independent, is to just pay a little bit of attention to the details and then write an extra or in an extra line, so where you set up everything and then you do the calculation, then the chances of you making a mistake is going to be less. So to calculate this one, so we have 24 times, we have -3. Then we have minus, and now we have B times C. Then we have 8 times 9. And then when you do the calculation, 3 times 24, that's going to be minus 72. So 3 times 72, that's 3 times 24, it's minus 72, and minus 8 times 9 is also 72. If you didn't pay attention to the sign and you had positive here, then that meant that this will be equal to 0, which is not, because then that is equal to 144, because 72 times 72, 72 minus 72 and minus 72 is minus 144, not a 0. If you had the positive here, then that was 0. So what does that imply? That implies that since it is non-zero, so the row are linearly independent. So let's do another one. So let's do B, just to drive the point home. We have 2, 0, 0, and 2. If we do the determinant of this one, then let's say if that's equal to B, then the determinant of B is equal to, so I say A, B, C, and D. So A times D minus B times C. So A times D, that is 2 times 2. If you write it, then you will not make a mistake. So 2 times 2 minus B times C. B is 0, C is 0. So therefore, this term becomes 0. Anyway, it doesn't matter because it's 0 is 0 by minus, and then 0 times anything is 0. So therefore, the determinant of B is equal to 4. What does that tell you? It's non-zero. When it's non-zero, that implies that the rows are linearly independent as well. So that's the first one, and it's not a very difficult one, but the thing is that if it requires for you to just pay a little bit of attention. Let's do another one. So we have talked about a transpose, that if we have, for example, if we have, let's say X is equal to X1 and X2, and also we have, let's say A is equal to -1, 5, and 7, and also we have 0, -2, this is -1, -2, and 4. So we have 2 by 1, and also we have 2 by 3. So what we want to do is that if we want to if you're asked to transpose X, so the transpose of X, you can write it either by having a just apostrophe like this, or you can have a T. It's same thing. It's okay with me whether you write this little apostrophe or you just put a T, but it doesn't really make any difference. But by definition, the transpose of this matrix means that if it's a row, then becomes a column, and the column becomes a row. What do I mean? So the transpose of X is that the row becomes a column. So it becomes X1, X2. That is the row. Similarly, you cannot do multiplication of this one. So then, because as I said before, even if multiply, I'm just using it as an example to tell you, because there's no product, because if you do a multiplication, it's not a product, because the column of the first one is not the same as the row of the second one when you do the multiplication. I'm just using it as an example. If you do the transpose of T, then that means that we have the rows and the columns becomes the rows. So we have -1, 5, and 7, and then we have 0, -2, and 4. So the transpose of A is this, and the transpose of X can be written like this. But let's do an example. So example, if we are asked, let's say, as I told you, if you take the product of X and A, you cannot take it because that's not actually doable because there's no product. That violates the rules that we have for multiplication. Therefore, so what you do is that if you're given an example to ask you to calculate transpose X, identity matrix of A, we have said that if when you take and you multiply A with an identity matrix, then that identity matrix will give you the same as this one. Just remember, when you're multiplying this, because this is 2 by 3, if you use, let's say, a 1, 0, 0, 0, 1, 0, 0, 0, 0, 3 by 3, still it's not going to work, but it is always good when you have 2 by 2. So that's what you need to do. Even though this one, you can do this operation, there is a product. But let's do this one, where we have the transpose of X, where we have X1, X2, and then you multiply it by the identity matrix times of matrix A, which is giving you again same thing like this, what it is, and that is -1, 5, 7, 0, -2, and 4. And when you do the multiplication, so we have 1 times 2, and we have 2 times 3. So therefore now we have the columns of the first one is equal to the row of the second matrix. And therefore, what is it telling us? This is telling us that there is a product. There's a product and exists the product. Product exists. And 1 and 3 is telling us that the matrix that we will get will be 1 by 3. So 1 row, 3 column. And that's going to be the product of those two. So this 2 operation, don't forget, you make sure that you write it in an exam. So X transpose identity matrix times A of the product would be, so we had in the next page, so we have -1, so it's -1. And then also we have 5x1, so we have column times row, and then x2 times 0, so it's 1. So x1 times -1, and then x2 times 2x, x2 times 0 is 0. So that's what we do. You take x1 times x2, then you multiply it by x1 times 5, x2 times -2, then x1 times 5. So we take this, and then we multiply it again, as I remember. If you remember from a previous video, that's how you do. You do this, and you do this, and you do this. And from here, the first one goes here, multiplied by this, then times the multiply of that one. So you do minus and plus. So let's do it. So we have, so we said minus x1, because that's times -1. So we have minus x1 because 2 is 0. Then for the second one, we have 5x1 and -2x2. If you remember, I'll just have it here. So x1 times 5, 5x1 minus 2x2. Same thing, 7x1 plus 4x2. That's how you divide. So then you have, so 5x1, then we have 7x1 plus 4x2. So that's your product that you will get. And that's how you calculate the transpose. The important thing is that when you transpose, as long as you remember that your row becomes column and your column becomes row, then you are fine. Also, as I said, if you have a two product, that the product is already giving to you. Let's say if you have a product of AC, this is two product of two matrix A and C. It's already been calculated, and then you're giving that the product of these two matrices is 24, 4 and 4, and 17, 3 minus 6. This is an example. And if you're asked to calculate AC, prime, or transpose, then that is equal, as I said, the column becomes row and the row becomes column. So therefore we have the column, which becomes row, we have 24, we have 4 and 4, and then we have 17, 3 and minus 6. So that's by rules of operation, that's how you do. Again, this is equal to, you can write it as a C transpose and A transpose. So that's the same thing that you can write it on. Now let's get to the more serious things, which we will have 3 by 3. And this one is something that probably you're going to see it in the midterm or in the exams, and this will be asking a serious question. Let's say we have an example of a matrix A that's 3 by 3, and the matrix is giving as 1, 5, and 1, and also you have a 0, 3, 9, minus 1, 0, and 0. So the question is that to find the ranks. Each of the following. So we have two examples, and then that's why I just say two following. So we have this matrix, and then they're asking you to find the ranks. Of course, I don't know, different instructors have a different way of calculating the ranks or determining the ranks of a matrix, but I find it this kind of easy if you take the determinant of these three of A, and again, if it's non-zero. If it's non-zero, then this means that the matrix is rank 3. The rank of this matrix A is equal to 3, means it's a 3 if it's non-zero, because none of the rows are zeros. So that's why rank 3. If the determinant of any of these matrix 3 by 3, let's say if that was equal to 0, then the rank of this could be equal to 2, or the rank of this could be equal to 1, where you have to do the row reduction operation, where you have to calculate and find whether it's a rank 1 or rank 2. But as far as this one, you can either use, but I'm going to do it in 2 ways. First one is just I'm going to prove it to you that the determinant, taking the determinant works, where it tells you what the rows or the ranks of this matrix is. And also you can do it using the row reduction, which we're going to do it together. So let's say for this one, we take the determinant. So the determinant of A is equal. Again, the way that you do in taking the determinant. So let's say if you want to take the determinant, the first one. So what you do is that you take this one and then the first number, and then you ignore these two. So let's say you have 1, and again, always you take the determinant plus, minus, and plus. That's how you take the determinants, how to minus, plus, minus, plus, minus. That's one. So you have a positive here. There's nothing negative in front of it. Then you multiply these by the determinant of these 4. So you have 3, 9, 0, and 0. Of course, there is a different way of calculating, taking the determinant of these 3 by 3 matrix, but I find that this is a more traditional way and it's more easier to understand. So that's why I'm going to do this one. But of course, I do admit that there is different ways you can calculate this one. So now for the second one, is what we do is just we ignore this. We take 5 and ignore the first column. So what we do is minus 5, ignore these 2, and then we take 0, 9, minus 1, and 0. So, and then that will be a matrix of, we have 0, 9, -1, and 0. So what we do is we ignore this and we ignore this. Ignore this and ignore this, and then we take the determinant. Then we say we have a plus 1. And then when you cover this and this, so you just ignore this and this, and then you take the derivative, the determinant of 0, 3, -1, and 0. So, and then you calculate, see what the determinant of this one is. 1 times, that is equal 1 times. Again, A, B, C, and D, same operation, A times 3. So A times D, that is 3 times 0, minus, and then you have 9 times 0. So you have 9, and that's times 0. So 1 times 0 is 0. And then -5, you take it, and then you calculate this one. 0 times 0 is 0. And then you have -5, and then minus 9. So just forget this one. Don't forget this one is -9 because it's very important. Then +1, and then you multiply. It is 0. 0 times 0 is 0. And then you minus -3. So when you do this one, so this becomes 0 because that's becomes 0. 0 times 1 is 0. Now you have minus. This one becomes minus, and minus is +9, and that is equal to, so that becomes +9 times -5, that is -45. And then you have +1 times +3, so that becomes 3, and that becomes -42. So that is the determinant, but the thing is that it's non-zero. So now you can tell that since it's non-zero, so since the determinant of A is non-zero, therefore the rank of this matrix is R of A equal 3 to write it and professionally. Now let's say, okay, so just to prove this one, let's do it in using a row reduction. When we do a row reduction, so we have A, and it's going to go a little bit fast, so I want to keep this video a bit short so you can go through it, and then you can, so -1, 0, 0. So let's say for the first one, in order to get A1, then we need to exchange row 1 and row 2. So row 2 and also a row 3. So let's change row 2 and row 3. So it's row 2, change, this one is row 3. So let's say stays row 1, same 1, 5, 1, and then we bring -1, 0, 0, and 0, 3, and 9. We are not doing anything here different. What we're doing, we're switching the rows. So like you have 3 equations, whether you put that equation first or last, it doesn't change anything, but we want to make it just sure that what we can see where we can do the elimination. And then calculate this one. So we need, here we have the 1. So we keep the first one. We keep row 1 as is, but we add row 1 to row 2. And this is going to be A1. And then now we're going to have A2. And then so we have, as we said, we keep row 1 as is, 1, 5, 1. And then we add row 1 to row 2. This becomes 0 because 1 plus -1 is 0. And 5, 0 is 5. And then we have 1 plus 0 is 1. And then we have row 3 stays the same, and 3 and 9. Now you see where I'm going, and therefore what we do is that here we can see we have 5 here, 5 here, 1 and 1. So what we do is that we divide row 2 by 5. So, but row 1 stays the same. So we have 1, 5, 1, and then when we divide, divided by 0, 5, it's 0, and then we have 5 divided by 5, it's 1, and then 1 divided by 5 is 1 over 5. Row 3 stays the same, 0, that's 3 and 9. So now we'll see. Okay, let me write these metrics so you can follow what I'm saying in this page. And then so this is what we got: 0, 1, 1 over 5, and then we have 0, 3, and 9. Now, let's see what we have. So we have 3 here, and 1 over 5, 1 over 5. So let's multiply this by 3 and add it to row 3. So 3 times row 2 and plus row 3. So the first one, row first one stays the same, 1, 5, 1. And then the second one stays the same as well, 1, 0, 1, 1 over 5. And then we multiply this by 3, add it to row 3. So when we do, this one will be 0, doesn't matter what you do to 0, multiply 0 is 0, 3, and then so we have minus 3 actually. So minus 3, and that would be 0. And then we have and then we have 9 here. So that's actually 1 over 5. And then here we have minus 3 times, so it's like here, minus 3 okay, so if we add minus 3, then that becomes a so it's 0, and that becomes 0, and then this becomes minus 3 over 5 minus 9. If you do this one, then you take a common denominator of 5, then that's minus 3, and then divided by this minus 3, and then minus plus minus 45. So, and this will be minus 45. So therefore, that is equal to 42. Equal to 42 over 5, or this you can write it at 8 over 2 over 5. So therefore we can write as an 8, 2 over 5. So the bottom line is that we have 3 columns that they are non-zero. So we can say in the bottom, in the end, that it contains, because I don't think you can reduce it anymore, contains 3 non-zeros, non-zero rows, because there's non-zero rows. Here is non-zero, 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 non-zero. So non-zero, non-zero, non-zero. Therefore, hence, the row of matrix A is equal 3, so that's 3. So whether you're taking the determinant or you're doing the row reduction, the bottom line is that you get this reduced form of matrix, which give you the same answer, that the rank of this matrix is 3. Now, let's do another one, and this time I'm going to do a different one because I want to make sure that the second one is 0 to see the differences and to prove what I'm saying is true. So we have 0, minus 1, and minus 4, and then we have 3, 1, and 2, and also we have 6, 1, and 0. So this is the matrix, and then now again just take the determinants of B, and that is equal to, we have a 0 first one, as I said, for the operation I explained before. I'm just going to go ahead and write it, and that will be, so we have 1, 2, because 1, 2, and 1, 0, and then minus times minus 1, and we're gonna have this one and that one, and it's gonna be 3, 2, 6, and 0. And then we have -4, and that is going to be 3, 1, and 6, and 1. So when we do the calculation, so this is going to be 0 anyway, it doesn't matter what you do with it, it's going to be 0. That's 1 times 30 minus 12. And that will be -4 times 3 times 1, and that's -6. So that is equal -12. And then this one will be -4 times -3. So that is equal -12, and then minus times minus is positive. 3 times 4 is +12, therefore that's equal 0. So we have a 0. Now, and you cannot just say whether it's rank 2 or rank 3 unless you have very good experience of looking at these matrices. Then you can say whether it's rank 2 or 3. But at this stage, the best thing for you would be to find the rank of this matrix is to do the row reduction operation. So we do the row reduction operation as we did it for the first one. A reduction operation, and that is that we write the matrix is 0, -1, -4, and that's, I'm going to go a little bit fast, but you can follow these steps and pause the video if you are kind of lost on the way. So interchange. So row 1 and row 3. So we have row 1 and row 3. So just bring this one up and bring this one down. So to do this, then we have a 6, 1, 2. Row 1 comes to row 3. That's 0, -1, -4. Row 3, row 2 stays the same. So we didn't do anything yet. Just we interchange row 1 and row 3. And then now, in order to calculate B1, what we're doing is that we divide row 1. So divide row 1 by 6. So when divide row 1 by 6, then what we get is 6 divided by 6 is 1. 1 divided by 6 is 1/6, and 2 divided by 6, actually this is 0. No, so if we bring 6, 1, and that is 0. Yeah, see, you can very simply make a mistake, and then 6, 1, because 6, 1, and 0, and then we have 3, 1, and 2, and 0, -1, and 4. So that's correct. And then you have 0 divided by 6 is 0, and then 3, 1, 2, 0, -1, -4. So you make sure that you copy the same thing and not to make a mistake. Now we have 3, and also we have 4, so we have 6 and 0, and then what we are doing now is that we are multiplying row 1 by -3. Row 1 by -3, and then we add it to row 2. So row 1 stays the same. Actually, here we have 1. So we have row 1 multiplied by 3, and we add it to row 2. So row 1 stays the same. So we have 1/6 and 0, and we have row 1 times 3 -3 plus 3 is 0, and then -3/6 is it's going to be 1/2, because you have this one is times 3/2 -3/2, that's -1/2. -1/2 plus 1 is 1/2, because take common denominator, -1 plus 1, plus 2, and then because this, if you take a common denominator here is 2 minus 1, and then here is 2 times 2 is 2, therefore is 1.5 positive. That's what you get, minus 1.5 positive, and then also here it's 2, and then we have 0 minus 1 minus 4. So that's what we have so far when we do the operation. Now we need to do further reduction, and that is that we take, if you look at the root 2, we have 0, 1.5, and 2, and then we take, multiply root 2 by 2, and then we add it to root 3. So when we add, so root 1 stays the same, it's 1 over 6 and 0, and then adding root 2, 2 times root 2, so 0 is 0, it doesn't change anything. And then this will be 1, and this will be 4. And we have 0, and minus 1, minus 4. So now you see what I'm intending to do and where we are leading. And therefore, so to get B3, then you need to do addition of root 2 to root 3. Root 2 plus root 3. So row 1 stays the same, 1 over 6, that's 0. Root 2 stays the same as well, 0, 1, and 4. And then you add these two, so we have a 0. 1 minus 1, when you add a 1 plus minus 1, that is 0. And then 4 plus minus 4, that is zeros as well. So therefore, we can see that we have only one row that is 0, and 2 of them are non-zero. So we can say that this is a resulting matrix, and this is resulting matrix, and with 2 non-zero rows, because there is non-zero rows too, here, 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 and in B3, and B3, which is correspond to this one, B3, and hence the row of matrix B is 2, because this is 2. And there is a linear dependence. This means that there is linear dependence in B. If you take row 1, which is row 1, is equal to row 3 minus 2 row 2, then we can conclude that matrix is singular. I think that should be enough for you to prepare for your midterm. Of course, this other stuff in terms of vectors and stuff, as I said, 2 things just to review. In terms of vectors, as I said, the vector has 2 things. It has the base, and it has a direction and a magnitude. So that's the base, and that is the magnitude part of it. And that's the direction. So this magnitude in terms of economic, it could be a unit, it could be a number of inputs or number of outputs in the direction that is going. And also it is this one. So when you're multiplying vectors, just one question where one of the students is asking me that if we have a vector 0 and 3, and that is equal to V, then what is 2V? The way that you write it when multiplying a vector, that does not mean that you have to get 0, 3 times 0, 3. It's not like this. That is no. So when you do whatever elements that you have is multiplied by the scalar that you have. Scalar here is 2, that could be a constant. Therefore, if you have calculated and then you got 0 and 9, that means this answer is wrong, because that's wrong. So, and then the answer to this one is a 0 and 6. If you get 0 and 6, because 2 times 0 is 0, 2 times 3 is 6. That's how we calculate the vectors. So vectors can change its direction if the sign has changed, but it going in the same direction, and you can start it anywhere. You can start it here and measure if you're going 0 to the right and 0 to the right and 6 up. So you go 0, originally you started here, but if you have a 0 and then you go 6 up, and then if it's a minus, it can go in this direction as well, but if the sign has changed. So you can start it anywhere, but the vectors, the direction goes, and then the magnitude, that's what is important for you. So again, 3 things with the vectors. Vector has a base, magnitude, and direction. And that's something that it does not change except when you are changing the direction of the sign. And then for multiplication of a vectors, all you do is just you multiply, and then also you can add by adding the 2 as well. Okay, so means this is twice as this one. Let's say if we have a vector where we have, if that's x, then it's a 0, and then it goes to 3. So that's 3. So you're going 0 to the right. If it was 1, then this one, it will be 1 and 3, 2 and 3. But since it's a 0, is going up. So this is a vector that is going on the same direction. But the only thing is that this vector is now twice as larger. So it's just extended in its way. So now it's 0 and 6. So it is 0 and 6. So that's what you need to do. So it's a collinear vector when you have 3 and you have multiplied by 2. The only thing is that it's a collinear, just it's twice as long, but it has the exact same direction. Again, I'm going to stop here because I will keep talking, and therefore we'll see you again with next video. Thank you.